You're standing on a shoreline in the rain. The drops are fat and slow, slow enough to watch one fall and step aside before it lands. They settle without a sound onto a sea as black and still as polished glass. It is raining on Titan today, and none of it is water. This is Saturn's largest moon, half as wide as our own moon, and it is the only world we know of besides Earth that has rain, rivers, lakes, and seas. Real weather in every sense we understand. But here, the rain is liquid methane. The sand is organic soot, fallen from the sky. The bedrock is water ice, frozen harder than granite at 179 degrees below zero. Titan runs Earth's weather with every ingredient swapped out. And hidden inside that weather are three puzzles we cannot yet solve. Today, we go looking for them. The sky above is a ceiling of amber haze, and somewhere above it hangs a sun you will never see clearly. From down here, it is only a bright smear, a lamp behind orange glass. That haze is a factory. High above you, sunlight is breaking methane apart, and the pieces are reassembling into heavier things. Ethane and long chains of carbon that drift down as a fine, dark soot. It has been snowing chemistry here for millions of years. It stains the riverbeds and builds the dunes. And below the haze, methane does everything water does at home. It evaporates from the seas. It gathers into clouds. It rains. Titan's raindrops swell to the size of marbles, and in gravity, 1/7 of Earth's, falling through air 4 times denser than ours, they drift down at the speed of snowflakes. Seen from above, Titan's ice hills are cut by branching river valleys you could mistake for the canyon country of Utah. The same shapes, the same logic, written in a different chemistry. Because weather, it turns out, does not care what the liquid is. It only needs something that can evaporate, condense, and fall. Earth chose water. Titan chose methane. The machinery is the same. And where the rain rarely reaches, along the equator, that fallen soot has been swept into dune fields larger than the Sahara. Dark waves of sand, 100 meters tall, marching in rows for thousands of kilometers. We know all of this because we were guests. In January of 2005, a probe fell out of Titan's sky. Its name was Huygens. It had ridden 7 years to Saturn on the Cassini spacecraft, and it spent 2.5 hours descending through the haze under a parachute, taking pictures the whole way down. At 40 kilometers up, the murk finally thinned, and there they were. Shorelines. River channels, branching like veins. A coastline on a moon. Huygens landed with a soft thud in damp sand, among pebbles of water ice worn smooth and round. The unmistakable signature of stones tumbled by a flowing liquid. It photographed a dry riverbed on another world. It also carried a microphone. On the way down, it recorded the sound of Titan's wind, a low, rushing breath. You can listen to it today. It is the voice of a world 1.5 billion kilometers away, so far that Huygens' radio signal, traveling at the speed of light, took 67 minutes to reach home. Nothing built by humans has ever landed farther away. 21 years later, it still holds the record. Near the North Pole, the rivers finish their work. Kraken Mare, a sea of methane and ethane the size of the Caspian Sea. Beside it, Ligeia Mare, wide enough to swallow Lake Superior. Cassini's radar could see through the haze, and when it looked at these seas, it found the first puzzle. They are almost perfectly flat. The largest waves anyone has measured are a few millimeters tall. There is wind here. There are tides. So why is a sea the size of the Caspian smoother than a garden pond? No one is certain. And it gets stranger. In July of 2013, radar caught something in Ligeia Mare that had not been there before. A bright patch, tens of kilometers across. A few passes later, it was gone. Then it came back. Scientists called it the Magic Island, and it is not alone. These features appear and vanish across Titan's seas. Some researchers argue they are patches of waves finally stirring. Others say fizzing curtains of nitrogen bubbles, released as the sea mixes. The newest work suggests floating rafts of porous organic ice, honeycombed like a sponge, riding just at the surface before they soak through and sink. 3 explanations. 1 radar ghost. The argument is happening right now in journals. But the deepest puzzle on Titan is that any of this exists at all. The same sunlight that builds the haze is destroying the methane it feeds on, permanently. Every methane molecule in this sky has a life expectancy of about 30 million years. That sounds long, but Titan is 4.5 billion years old. On that clock, its atmosphere should have run dry ages ago, and the seas hold nowhere near enough to refill it. Something does not add up. So there are 2 possibilities. Either Titan is quietly resupplying itself, perhaps from a hidden crust of methane locked in ice, venting upward where the crust warms. Or we have arrived, by sheer luck, near the end. The last rains of a world whose weather is slowly running out. One of those is true. We do not know which. We will. Right now, NASA is building Dragonfly, a car-sized drone with 8 rotors, designed to fly in that thick, gentle air. It launches in July of 2028 and arrives in 2034 to hop from dune to dune seeking these answers. Everything you have seen tonight, the slow rain, the carved valleys, the vanishing islands, runs on a whisper of light. Sunlight at Saturn is 100 times weaker than at Earth, and the haze keeps most of what remains. A world in permanent dusk, and still it makes weather. Which leaves a question bigger than Titan. Weather is the gift of a steady star, and ours has been steady for 4.5 billion years. It will not always be. Next time, we stand on Earth in the far future and watch what happens when the sun itself begins to change.